Okay, so this is actually a good one for us to go over, number 9 from the forces of vector quantity worksheet. Reason being, this is exactly the situation we're going to have in our lab. Okay, we're going to have a cart on one of those tracks, and we're going to have a pulley, and then hanging over the pulley is going to be a mass. Okay, and we're going to be accelerating the entire system, okay, using that hanging mass. So we have these two blocks set up. Okay, mass 1 is 6 kilograms. Okay, so we know that there's a force of gravity here, okay, of 6 kilograms, or sorry, of 558.86 newtons, okay, acting on that mass, okay, and the other mass is 4.5 kilograms, and friction is opposing with 4 newtons worth of force. Okay, so those are the forces within the system. So now that I know that, now I can simplify the system to be just one mass, and that mass will be 10.5 kilograms, and it's going to be pulled this way by 4 newtons worth of force, and it's going to be pulled this way by 58.86 newtons worth of force. Everybody all right with that? Okay. So what can I calculate right now? Net force, okay, and I can calculate that using the vector sum of all forces. So that'll be force of friction plus force of gravity acting on the 6 kilogram mass. Okay, so we'll have our negative 4 newtons plus our 58.86 newtons. Okay, so that's going to give us 54.86 newtons. Okay, everybody all right with that? So we got a net force of 54.86 newtons. Okay, now it's asking me in the question, calculate the acceleration of mass 1. Do I divide by just mass 1, or do I divide by the whole system? Whole system, right? The whole system is accelerating at the same rate, so I have to reflect that. Okay, so the acceleration of the system will be the net force, 54.86 newtons, divided by the mass of the entire system, which is 10.5 kilograms, okay, which will give me my 5.2 meters per second squared, and because it's for mass 1, okay, that will be down. Okay, that's the direction that mass 1 is moving. Okay, so the lab we're going to do next week will be a situation just like this, except instead of having a mass on the table, we'll have, I mean, the cart's still a mass, but it'll be a cart with wheels. Okay, and it'll roll. And all we're going to do is change where in the system the mass is. Okay, we're never going to change the mass of the system in the experiment. We're just going to transfer masses from the cart to the pulley. Okay, and so we're going to have more and more mass driving the system. Okay, but still the same mass in the system. Does everyone kind of follow me there? So basically, we're seeing what is the effect of net force on acceleration by changing the net force, by putting more and more mass over top, but not changing the mass that we're accelerating. So that's what we'll be looking at with that lab. Okay, any other ones?
Could you go over number 9?
Wind kind planes? Okay. Okay, so avalanches move down hills at great speed. The slope is 50 degrees, so that's a pretty steep mountain slope. Okay, mass of the snow is 2,500 kilograms. I'm going to represent the snow with a box, because that's how I draw everything. The acceleration is 6.5 meters per second squared down the hill. Okay. So what's the force of friction between the snow and the mountain? All right, so the two forces that are involved here are F parallel, pulling the snow down the hill, and the force of friction resisting the snow going down the hill. Okay, those are our two forces. Now, what can I calculate right now, since I know the mass of the snow and the acceleration of the snow? What can I calculate with that? F net. Okay, so I'm going to calculate F net right off the bat. M times A, so 2,500 times 6.5. Okay, so I've got a net force of 16,250 newtons. And that's down the hill. All right, so I've got my net force now. The other thing I need, if I want to calculate the force of friction, I'm going to need this, because the other way to calculate net force is the vector sum of all forces. So that'll be F parallel plus the force of friction. So I need to get F parallel by drawing my triangle, okay, inside. And using that triangle inside. So I've got my force of gravity, which will be m times g. So 2,500 times 9.81. All right, so we got 24,525 newtons. Okay, and now I can calculate F parallel. Okay, F parallel will be the sine of 50 times 24,525 newtons. Okay, so we're looking at 18,787 newtons. Obviously, I'll keep all my decimals for any other operations that I'm going to do here. All right, so now I know F parallel. And I know F net, so I can use the vector sum of all forces in order to find the force I don't have, which is the force of friction. So I'm going to isolate the force of friction by subtracting F parallel over to the other side, like so. Okay, everybody with me on that one? Okay, so now when I plug in those numbers, I'm going to have my net force, 16,250, and I'm making down the ramp positive here, okay, minus the 18,787, okay, and that will give me my force of friction. So my 16,250 minus the answer I got here, okay, and so I get a number that's up the slope. I'm not sure why it's 2.55 on there. It should be 2.5. There shouldn't be a second number there, or third number there. There's only two significant digits in this question, so it should just be 2.5 times 10 to the 3 newtons up the slope. Okay, all right. Any other ones? Okay, keep going then, guys. Okay, so we got a request here for number 10. Okay, it's another system question. So we've got these two masses hanging over a vertical pulley. Okay, A's mass is 10 kilograms. Okay, so A is 10 kilograms, which means the force of gravity acting on A is 98.1 newtons. Okay, B's mass is 18 kilograms. Right. Okay, so the force acting on it is 176.58 kilograms. Sorry, newtons, not kilograms. Okay, so now I've got those two forces there. And so I want to calculate the acceleration of mass A. In order to do that, though, I need to know what about the system. The net force. Yeah. I'm going to have the two forces that are acting in the system. So what I want to do is, again, simplify the system, okay, so that I'm reflecting that I have 28 kilograms worth of mass, okay, that's being pulled this way by 176.58 newtons, and this way by 98.1 newtons worth of force, okay, because these two masses are what's going to drive the whole thing to move. Okay, so I can calculate my net force right now by doing vector sum of all forces. So 176.58 minus or plus negative 98.1, all right, which should give me 78.86. Is that right? I feel like it's not. 78.48. Okay. newtons. Okay, so I've got my net force, okay? It wants me to calculate the acceleration of mass A, but I mean mass A and mass B accelerate together, so I need to calculate the acceleration of the system instead. All right, so acceleration will be F net, okay, divided by mass, so that'll be our 78.48 divided by 28 kilograms, and that will give us our 2.8 meters per second squared, and there should be a vector on that of up as well. Okay, because it is going to accelerate upwards. You did only ask about that. You may. Okay, any other ones, guys?